Hello there. So in this video, we're looking at how we can use trigonometric identities to prove that one side of an identity is the same as the other side. So basically, this topic can be kind of tricky because you have to take all of the trig identities that you've learned in the course and use them to solve things like this. And it's very hard to teach because there is no strict method. It's not like you always do step 1, step 2, step 3. It's going to be completely different depending on the question. The main piece of advice I can give, though, is to really look at what you're given to start with and figure out what sort of things you might use. So looking at this before I start, I see these secs. So I know I'm probably going to change those into 1 over cos. Here I've got a tan squared. So I think tan squared might at some point go to a sine squared, well, of pi over 2 over cos squared pi over 2. So just because tan is sine over cos, I know it might have to be written like that at some point. And then the other really important thing to notice is that here we have a theta, and here we have theta over 2. So you might not have thought about how to change a theta to a theta over 2 before, but it's actually kind of the same thing as changing a 2 theta to a theta. So it's just a double angle formula. Like if we were given something in terms of 2 theta, and asked to change the theta, we'd know to use a double angle formula. And same thing here. It's the same thing as changing theta to theta over 2. So we just got to bear that in mind as well. And so if we actually start doing this then, the first thing I would do is turn each of these into 1 over cos. So we're going to have 1 over cos theta minus 1, and then 1 over cos theta plus 1. And these fractions are kind of a pain, so I'm going to multiply everything by cosine, which will give me 1 minus cos theta on top. So multiply this term and this term by cos. And on the bottom, it will give me 1 plus cosine. So that's great. Now though, that's still not quite looking like the sine squared thing. So the next thing I'm going to do is probably apply that double angle formula stuff. So remember, I'm always thinking of this as being a cos 2 theta. And what might be helpful is to write out, like, imagine if it was cos 2 theta, I just do this in a different color. Then I could rewrite cos 2 theta by the addition, or by the double angle formulas. I could write it out as 2 cos squared theta minus 1, or as 1 minus 2 sine squared theta. And I know we could write in terms of cos squared theta and sine squared theta, but we probably don't want both of them on top or bottom, so it's probably going to be one of these two. And that means that if we just had cos theta, and we wanted to write it into theta over 2, it would be 2 cos squared theta over 2 minus 1, or the other one would be 1 minus 2 sine squared theta over 2. We've got one of those forms. And now again, you've really got to think about what you're trying to find. So we're trying to find tan squared. Like we said, we can get that by doing sine squared over cos squared. So what I'm thinking is I probably want to change this cos theta on top into the sine squared version, and this cos theta on the bottom into the cos squared version. And then hopefully things will cancel out or something will happen so that I end up with sine squared over cos squared, and that will give me the tan squared that I want. So it's really important that at this stage, you don't necessarily know exactly what's going to happen. You can just kind of make your best guess based on what you want. So if we swap back to the blue pen, and this top bit, I'm going to change to 1 minus, and then this cos theta, I'm going to represent as this instead. So as 1 minus 2 sine squared theta over 2. And then this bottom bit, I'm going to write as 1 plus, and I want my cos squared version on the bottom. So 2 cos squared theta over 2 minus 1. And now I'm going to simplify this out. So on the top, 1 minus 1 is nothing, that cancels out. And if you take away the negative of this, this becomes positive. So on the top, I just have 2 sine squared of theta over 2. On the bottom, 1 plus, take away 1, they cancel out. And then it's positive this, so I just have 2 cos squared theta over 2 on the bottom. And then I can cancel out the 2's, and I have sine squared over cos squared, so that is just going to be tan squared of theta over 2. And that's it. We've got what we wanted. So I just want to say overall, this is a fairly tricky one. And we probably couldn't really have got there without having this in mind from the beginning. And we certainly couldn't have got there without noticing the double angle formula bit. So just watch out for those sorts of things. But yeah, I hope that all made sense. If you have any questions, then let us know down in the FAQ. And I'll catch you in the next video. Thanks.